Okay, here are the objectives for this video. We're going to write a linear combination of unit vectors, find direction angle, and we're going to find the magnitude and direction angles. We've already done some of this in class, but I wanted to go over some of what was behind the linear combination of unit vectors I and j. I, as you know, is not imaginary. So these are actually vectors, and if you're going to draw these vectors, the component vector, remember, starts at the origin, and then this one goes to the point 1, 0. So I would look like this. J would be 0, 1. And this is J. And so these are called standard unit vectors. They are 1. They have a magnitude of 1. So the magnitude of I would be just 1, and the magnitude of J would be 1. Okay? The horizontal and vertical components of vector v would look like this. It would be v1, I, v2, v sub 2, j. So you're writing it as a linear combination. If this were in component form, it would be v sub 1, v sub 2. And so these are different forms but the same component vector. Okay, so here's an example. If u is a vector with an initial point at -1, 7 and a terminal point at 5, 3, then write u as a linear combination of I and j. And so what we're going to do first is A. We're going to write it in component form. And remember that we're going to do, this is initial and this is terminal. So we're going to do terminal minus initial. So to write it in component form, I would have 5 minus a -1, and I would have 3 minus 7. So in component form, this would be the component vector 6, -4. And then to write it as a linear combination, you would just say 6i minus 4j. And you're done. So you can do the same vector operations with vectors written in either form. If it's written in a linear combination, you can write it as component form, but it's pretty simple either way. And the only thing I would do is just add this u equals to this. Okay, here we are at the meat of today's lesson. This is finding direction angles. Take a minute to copy down this diagram. You'll probably want to stop the video so that you can copy each part. Notable parts here is that this vector, u, is in standard position with the terminal end at 0, 0. It makes a right triangle, and then this is theta. This is the x component and the y component of this vector. Okay, so pause here and write some of this down, but I'm going to keep going. Okay, so u is a unit vector. It has a magnitude of 1. What that means is this length is 1. And so we are back to the unit circle, because remember that the unit circle, right, the radius of the unit circle is 1. So if this has a magnitude of 1, this is something off the unit circle. So for instance, if the magnitude or length of this is 1, right, then I know that y, this y coordinate, is going to be the sine of theta. And the x coordinate is going to be the cosine of theta, because this point on the unit circle is cosine theta, sine theta. And we remember that from the unit circle. Theta is a direction angle from the x-axis counterclockwise. And you see my arrow here for theta. All right? So for all vectors, not just unit ones. So for instance, if this is not a unit, then this would actually have a magnitude. This would actually have a magnitude. All right? So the component vector here would be x, y, or, let me write it correctly, or cosine theta, sine theta. Okay? So for v, if we're talking about v, we would write it the magnitude of v times the component vector of cosine theta, sine theta, where the magnitude is a scalar. Remember that? Just a regular number, a scalar. Another way to write this would be as the component vector. So I would say the magnitude times cosine theta, and the magnitude of v times sine theta. A lot of notation here, but really it's just numbers, not a big deal. Okay, so this is the magnitude, and this is the direction angle. Theta is the direction angle. Direction angle, okay? So if you're looking for x and y coordinates, the x coordinate is going to be equal to the magnitude of the vector times cosine theta, and the y coordinate is going to be equal to the magnitude times the sine of theta. All right, and that's all from the diagram using direction angles. So u is my vector, v is my vector, and then the direction angle is theta, and then this tells me how to find x and y components for any vector, not just a unit vector. All right, so now that we've done that, here we are at the tangent of theta. We know that the tangent of theta is sine theta over cosine theta, and we know that as an identity. Okay, so if the vector v can be written as a linear combination of ai plus bj, then the tangent of theta is going to be equal to the y coordinate, which is what we have over here, right? The y coordinate, the magnitude of v sine theta over the magnitude of v cosine theta, or in other words, b over a. So the component, right, that's the component vector. You've got the arrows between there. This whole thing, let me change colors, this is A, and this is B. So if it's a linear combination, I can write it like this. Now, this is all the theory. So on the next screen, we're actually going to do some problems. Okay, the problems are so totally easier. So, for instance, on this one, if I'm just going to draw this vector, right, the component vector is 3, 3. So over 3, up 3, and here's my vector. Well, if this is 3 and 3, then this is a 45-degree angle, right? Because this will be 3 square root of 3, or 3 square root of 2. So that's a 45-degree angle. So it's pretty easy. But the tangent then of theta will be, this is component form, right? 3 over 3, which is 1. Well, theta is going to be 45 degrees. And you're done. So the same thing here. Write it in component form, 3, negative 4. And the tangent of theta is going to be negative 4 over 3. So on my calculator, second tangent is going to give me theta is negative 53.13. Well, okay, what quadrant is that in? Right, it's in the fourth quadrant. So let's figure out what it is a positive number. So I'm going to take 360 degrees minus 53.13 degrees, and my actual answer for theta is going to be 306.87 degrees. Not a big deal. Just take y over x and you got it. Okay, these are similar problems. What you're doing is you're given a point written with magnitude and direction, and you're just going to find the magnitude and direction angle. So this is pretty simple. I'm going to have the magnitude is going to be here, right? So the magnitude of v is just going to be 8. And then the direction angle is going to be right here, 135 degrees. That's it, you're done. Okay, now it's a little harder on this one. This is on B is a linear combination. So if I write this in component form, I have negative 4, negative 7. The tangent of theta is negative 7 over negative 4. So theta is going to be a negative angle. Actually, it's not. It's going to be 60.255. But when I look at my actual component, this component said that it was negative, negative. X and Y are both negative. Well, that's the third quadrant. 60 degrees is not in the third quadrant. So I need the 60-degree angle in the third quadrant. So I'm going to have to actually find my direction angle, I'm going to have to add 180 plus 60.255 to get the actual direction angle, which is 240.255 degrees. And that's why, and it's your component that tells you what quadrant you're in. Because if this is the vector in standard position, so it's pointing to the third quadrant. So I've got to have a third quadrant angle. All right, now I just need the magnitude. The magnitude of V is the square root of 4 squared plus 7 squared, which is the square root of 16 plus 49, which is the square root of 65. And that's my answer. So there's the short answer, and here's the long answer, and that's how you do it. Okay, one more example. This is finding the component form of V given the magnitude and angle it makes with the x-axis. Right, so the magnitude is 1, and theta is 45 degrees. So remember, a component form looks like this. I have the magnitude of V, cosine of theta, the magnitude of V, sine of theta. Fill in the blanks. So I have 1 cosine of 45 degrees, 1 sine of 45 degrees. Well, we know what the cosine and sine of 45 degrees. So this is actually the square root of 2 over 2, square root of 2 over 2. And that's it. It's pretty simple. So I'll see you in class. We're just continuing to learn more and more about vectors. Please review that, and also some things from 5.4 and 5.5. Please review as you go along. And we'll probably have a quiz before too long.